All right, welcome to episode 21 of Writing Swish, a Lisp for Swift, written with Claude Code. Another productive week. All this functionality highlighted was accomplished, so let's go over that. We got support for sets as functions, the set question mark function, the count function, the vector question mark function, nil question mark, list question mark, sum question mark. We got multi-arity support in functions. We've got the and or macros. We've got the loop special form, the recur special form. We've got the first and rest functions now working on maps and sets. Mod, rem, quote, number, question mark, integer question mark, float question mark, ratio question mark. The inc and dec functions, zero question mark, pause function, negative question mark. I don't know how you call these. Maybe you say just predicate, or maybe you say, I know in the Lisp, common Lisp world you used to say p, like even p. I'll just do question mark, odd question mark, into empty question mark, non-empty, every question mark, sum, mapcat, complement, identity, apply, map. You can read all these. I'll go through some of the important ones. Conj, next, sequin next for sequences. We've got param destructuring and sequential destructuring and map destructuring. We've got the try, catch, and finally throw special forms. We've got the cond macro. We've got doc strings for namespaces. We've got threading macros. We've got the associate and to get in functions and update in. We've got select keys, merge with. We've got atoms on deref. Special note there, it's for single threaded. We don't have compare and set functionality yet. That'll come later. We've got take while, and we've got doc strings, or the doc function I should say, as well as doc strings for all the built-ins. All of this is part of, and here's what's coming up. Actually, let's switch over to when I was asking Claude what it would take to implement the Jank Clojure test suite, so we can see how close we are to implementing Clojure, and it came up with this roadmap. So here's our vision. Eventually, I want to have an embedded runtime, so you can embed Swish in your Swift app, and have Swift Swish interrupt. And I'd like to use, instead of right now we have a tree walk interpreter, I'd like to have a bytecode interpreter, and I'd also like to be able to compile a Swift for extra performance, or to create libraries that you can link into your Swift app. So it came up with this roadmap. Basically we have tier 1, and basically tier 1 is all finished. We have destructuring, the try, catch, finally throw, special forms, the cond, macro, threading macros. We've got winlet and iflet, and we implemented these missing map operations. And we have atoms, but we do not have the compare and set semantics, and I really want that. We'll do that later when we do some multi-threaded stuff. And so all of tier 1 is done, except with this note of compare and set semantics. And then right now we're working on tier 2. So we've got a lot of these. Where are we? In our to-do list, we're going to do work on drop while. So we're like right here. So we've got all this work to do for tier 2. And if I remember right, tier 2 is all we need for, so then we can start looking at the Jank Clojure suite and seeing if we pass. So that's where we're headed. Let's look at, one thing to note here is we now have 1,361 tests. You can see them all over here, almost all of them, testing all that functionality we've added. We've added stuff, a lot of the functions that I do, I prefer, if we can, to just copy the code over from Clojure, from clojure.core. And if there's any functions that we need to implement to be able to do that, then we do that. Otherwise, we do a built-in. So here's clojure.core right now. And you see we've got namespace, doc strings, the and macro with multi-arity. There's the doc function that gets the metadata and prints it out. Defen, there's the defen macro with support for doc strings and metadata. Or again with multi-arity, some, when, assert args, which was needed for some of the macros, like the when let macro right here. The if let macro, we got a second macro which was needed by cond. And here's our threading macros with the loop and recur forms. And another threading macro. And then just a whole bunch of little functions that we needed. Into is reducing, using the reduce function. So a lot of functions that we've just basically copied over from clojure.core. And you notice they all have doc strings and metadata. So then if we look at our demo, our little demos namespace, you can see it's using a doc string and some metadata. In the hello function, I forgot to point out last week that we've got the do special form being used. And here we have a version of Fibonacci with the loop and recur. Runs much faster than the recursive one, as well as not running into our limit on the call stack, which is 1,000. There's our con macro. And here's an example of our threaded macros. So we can run our demo here, and you can see it running out. Let's just run it for, let's just run the REPL. We acquire our demo. Okay, there it is. It runs. If you remember, if we do a fact of 20, it works. If we do demo fact of 21, we get an integer overflow. And I think if we still do if we do fact 2 of 21, we'll still get an integer overflow, which is correct. But I think it's you can't really tell if it's faster or not. And if we do demo of fib to a large enough value, let's do 20. Kind of paused. If we do fib 2, you see the result comes back immediately. So that is an update on what we've got going. Going forward, I'm going to implement these sequence utils and maybe lazy sequences got the transducers we need to do. We need to add some closure string functions and set functions, get some IO stuff going on, and then maybe we can conquer the Jank closure test suite. So I'm really happy with the progress so far. I actually think that this is becoming fairly useful fairly quickly. So please let me know what you think. If you wanted me to show things differently, go more into depth at how I'm prompting things or whatever. One note I'll make is that when I do prompt and I'll tell it to implement a function, when it's all done doing its thing, I will typically go ask, are there any refactorings we can do? And it will go and analyze, at least to analyze what we just did, and give me a good suggestions on things we can do. And it's even caught some bugs that way. And if I'm more specific and say analyze all the code in the entire project, are there any refactorings for that, it will come up with some stuff too. So I'm trying to keep all the code in order, somewhat reasonable, and it seems to be doing a good job. So again, please comment below what you want to see, whether you like what you're seeing, whether you want to see something different. In the show notes on YouTube, you can find the repo where I'm keeping that up to date. You can buy me a coffee to support my work. Like and subscribe, and I'm also looking for work. So if you need some Clojure help, or if you need some Swift help writing an app, or you need advice on architecture, whatever, I'm available. Get in touch with directly with direct message. Comment below. You can email me at rod@infinitenil.com. Go to infinitenil.com. Look forward to hearing from you. Until next time.